Okay, so let's continue the discussion here with so-called demonic nondeterminism. And it turns out demonic nondeterminism is introduced by the small step semantic. So the small step semantics for or are as follows. We got or, we're going to have two rules like before, or one small step semantics. And that rule says that S1 or S2 in state S evaluates to in the small step semantics in one step to whatever S1 S evaluates to, and the or 2 S1 or S2 S evaluates to whatever S2 evaluates to in S. So I guess one thing to note here is that, whenever you have a construct that's an or, so there's no constraint on the application of these rules. So whenever, so that means that both rules apply to every statement of the form S1 or S2. So you can always apply either of these rules. Now, when we talked about this definition up here of loop, where I just said, loop is this program that loops forever. If we go back and we look at down here, that means that, remember that loop, you showed this in homework, that in 3 steps, I think, loop S evaluates in some number of steps, I think it's 3, to loop S. So it evaluates to itself. Now, since there's no constraint on the application of these rules, both rules always apply. That means a program that looks like, let's say, loop or gets the value in 1 in state S, under the first rule can evaluate to loop whatever loop evaluates to an S. So this is the rule B, or 1, or the rule or 2 says that loop or x gets the value of 1 in state S evaluates to x gets the value of 1 in state S, which actually in one more step evaluates to a terminating state, which is S, where x evaluates to 1. But this one, loop, just keeps going. And this one up here just keeps going forever. So the idea here is that the small step semantics do not suppress infinite loops. Or abort. Remember, we added, if we have statement and it's got, the syntax has x gets the value of a, or skip, or ... and now we have S1 or S2, and we have, if we add abort, and there are no rules for abort, so that means that for every S and S1, which are states, abort S does not evaluate to any state S prime. Now, in the angelic semantics, in the angelic big step semantics, abort would behave just like the loop program. Whoops, no, that should be an or. Is going to evaluate to S, where x has the value 1. And that's the only thing. So this is the BSS, or the OR 2 BSS rule says that. But in the we could get either one. I think we proved in an earlier class that abort was similar to loop in both the BSS and the small step semantics. Big step and small step. Okay, well, that's the section on nondeterminism. Thank you for listening.